Yeah, we'd like to introduce a technology called Snap Signal. So within our industrial automation environment, the internet and industrial automation, it's emerging. So there's so many machines out there at the moment consuming data. It could be a simple conveyor system, or it could be something a bit more complex, like a chemical processing plant, for example. That data's there, but how do we make it available to us? This data could be used to make improvements in efficiency and productivity. It could also be used to give us like a beneficial cost saving in terms of our company business and our economical structure. And this data, how do we interpret the data? So we've got data being expressed between machines day in, day out for different processes. How do we interpret this data in such a way that people understand? So within our industry, you've got admin, you've got warehouse staff, you've got your engineering team, you've got mechanical engineers, control engineers, logistics, warehousing. How do we get that data and make it visual to people so that they understand what it is? It'd be great if we could create, dashboards or, like bar graphs, pie charts, trend graphs, or even illuminate the machine. So as people walk past the machine, they know instantly it's red or it's green. So that will basically determine the status of the machine just by visually looking at the machine. Or wouldn't it even be better if you could monitor your machine from anywhere around the world? So perhaps your colleagues or your employees are on holiday or something in the Bahamas, having a pina colada or a cocktail or something. It'd be great if we could monitor the machine from anywhere around the world. So the IT and OT world, it's emerging, and we at Tech Banner are excited to present to you our solution, a way in which you can unlock your machine's true potential, and it's known as Snap Signal. So my name's Alistair D'Souza. I'm the Business Development Manager for our IIOT products. So it includes Snap Signal technology, which we're going to speak to you about today. And because IIoT is a large topic, there's other bits of hardware that are included within IIoT. So it'll be the field bus, devices like PLCs, controllers, HMIs. So it's quite a big catalogue of products, really. I'll let Craig introduce himself.
My name is Craig Davis. I look after the vertical markets, so that's your food and bev, oil and gas, automotive, those sorts of things. And Snap Signal and data collection and visualization of that data is massive in not just those industries, but everywhere. So we're going to talk through some of the products. But before that, we'll talk about Turk and Banner, so they're two separate companies, and that merriment and joint venture here in the UK, which has been going on for the last over 25 years. So Banner is based in the States, massive engineering company there, sensors, vision, safety, and then it just seemed right that years ago Turk would come together with them, who also specialise in sensors, connectivity, field bus equipment. So that's the locality of the joint ventures throughout the world. Ours in the UK being the oldest, 1997 it was incorporated. And then that's Turk across the world, largely in Europe. And Banner, again, stateside, massively in the USA, South America. And these are some of the markets that we're serving. Some of these may be where your companies are based. So a lot of automotive, F&B, and warehousing, conversion equipment, packaging, that sort of thing. This is sort of a product overview. So if you think automation and control, there'll be something in our product portfolio that will cater to that. There's over 100,000 products from Turk or Banner that we can offer on. And this brings us to snap signal. So what is snap signal? It's the idea of taking a legacy piece of equipment, taking it from just controlling, feeding back to the PLC, and almost piggybacking on that signal and taking it to the next Industry 4.0, which is sort of where everything's heading. I'm going to look through some of the products that make that possible. Do you want to speak through?
Yeah, sure. So why snap signal? So what it is, it's condition monitoring and predictive maintenance. And with that in mind, that could be a cost saving potentially for your business. It's an easy IIoT solution that we can adopt not only to to greenfield sites, but brownfield sites as well. And what is it? It's a combination. Snap Signal's a portfolio of products, not just one product. It's our little converters, our controllers, edge gateways, and our connectivities, splitters. But it's also the software and the ability to talk to our cloud, known as Banner CDS, or third-party clouds like Amazon, AWS, Microsoft Azure, etc. And the idea is to unlock the potential of existing machines on your site. And how do we do it? So there's a process in which we do it. We basically capture the signals from your sensors on the sensor level, and then we can convert that into a unified protocol. And then from there, we then distribute it from our controller up to the cloud, to AWS, to an API, to a web server, wherever you want to. This is a good topology which pretty much demonstrates what Snap Signal is, and we've got a demo board as well, and it's a good graphic because we call this the IIoT data elevator. So at your field level, you've got different sensors, whether it's analog sensors, CTs, serial Modbus sensors, discrete sensors. What we're trying to do is trying to capture all them signals and bring them into one unified serial protocol. So from here, if we get an analog signal, we want to convert that into Modbus RTU, if you guys are familiar with serial field bus. Once it's in the controller, we can then distribute that data out. So we can talk to PLCs on Modbus, TCP, Ethernet IP, Profinet. We can talk to AWS, SCADA systems, HMIs, PLCs, or we could even speak via HTTP to web servers. And we can do that hardwired using hardwired industrial Ethernet, or we do have 4G options as well. And there's a few myths. People seem to think that IIoT it's required for greenfield sites, but we're finding that most of our customers are at brownfield sites, and they're looking to adopt IIoT at an old factory, for example. And companies they're quite scared of adopting this sort of technology and getting their data up to the internet because they think it's going to cause some downtime on their machines, and there's going to be expensive meetings and things like that, and it's going to take a long time in order to get their data up to the cloud. But that's not the case with Snap Signal. It's quite modular and it's easily adoptable. So if we go through some of the products, this is a few here, controller and some splitters, etc. And if we look at a few topologies as well, it's a good graphic to give you a bit of an understanding. So these are just tanks, whether it's liquid or powdered matter. We've already got our ultrasonics or radar sensors pointing down into the tank. They're quite large tanks as well. We can take that 0 to 10 volt signal from the sensor and use one of our T-splitters. So this is just a parallel splitter, so it's just a parallel 5-pin. And we can take that signal, keep this signal going back to the PLC, so it's doing its main job, but then we can tee off, get that analog signal, convert it to a Modbus signal. So we have the little snap converter, so that's pretty much it. It's the size of an AA battery. And what that's doing is converting analog signal to Modbus. And then from here, because it's Modbus, it's daisy chainable, so everything's got an ID. That's a parallel splitter as well. So everything's going into our controller hardwired via Modbus, and then we can gather that data, we can scale the data, we can do some simple maths on that data, and then we can publish that data up to the cloud via 4G. That's our banner CDS, but it could be anyone's cloud, like I said. We can also visualize on our machinery. So not only can you get sensor data out, you can actually output to LEDs. So this application, it's showing some roller drums. So as these drums, as the drums, run out of tension or they run out of product, we can visualize them on our LED lights. So it's a good local indication. So green, the drum's a fresh drum. As the drum gets used up, the level of the light will predominantly go down. So the controller within that is taking the 4 to 20 milliamp signal and it's scaling it to a 0 to 100 scale, for example, on the light. And then out of that, we can send that data up to the cloud. So we can say it was a green status at this time of the day. At this time of the day, when it showed up as red, you get another status. So we can monitor that then from anywhere around the world on the cloud.
Where's the calculation done?
Yeah.
That's converting the roll size, for instance, to a light?
Yeah. So you scale it in the controller. So on these, this is an analog. So if it was a 4 to 20 milliamp analog converter, it's already in there scaled as 4,000 as a digital value, 4,000 to 20,000. So you then do the maths and the logic within this controller.
So that's a programmable.
You can program it via simple read-write rules, which is you read from ID1, Modbus ID1, and then a write would be to write to a light to output. But you could, like I said, you could use the read-write rules, which is very basic, statements. But you can also
read-write rule like a lookup table.
Sort of. It's more. Yeah, it's like a table, but it's like if sensor 1 equals 20, then you could make a local register in that 100. So when it's 20 milliamps, when it equals 20 milliamps, you could make an output on that Modbus light show up as 100. But you can also program it via MicroPython and Script Basic, so it can get really powerful, to be honest, if you want to do it that way. So it could be used as a standalone controller, but as well you can use it as a slave device when connected to like a Siemens PLC, for example, on Profinet. And this is like some of our OEE applications. So this is just a simple bottle counting application. So when the machine's running at its, at a decent speed, we can have our tower lights showing green. If it's slowing down or if there's an issue with the machine, we can illuminate the machine amber or red. And again, same sort of topology. We just take in the signal. That's a Modbus signal. That's a Modbus light. So we don't need any converter. We're just splitting it off. This is a discrete signal. So we're going to take that discrete signal, which is either on or off, convert discrete to Modbus, and then from there, using one of our little S15 converters and into the controller, and then we can publish it to the internet or a PLC or whatever you want to do with it, really.
And what that's doing there is tracking your production data, so like a bottle count along the line, and then you can use that for productivity overall, how much your factory is going to be outputting, or reasons why maybe at this certain time your factory was running slower, you had maintenance, downtime, that sort of thing. So dive on the products themselves. Again, this is the topology, the escalator that Alistair mentioned. Where we're focusing on is the conversion and capture, taking that signal from the sensors back to a unified protocol.
Yeah, so we've got, like I said, the size of a AA battery. And when I first started with TechBanner, there was only about 20 of these converters. But now I think there's over 40 of these converters, and Banner constantly keep bringing these converters out. So they're simple plug and play functions. They're Modbus as well, so you can pretty much use this with anyone's sensor. So if it's got a 4 to 20 milliamp, it doesn't have to be a Banner sensor. It could be anyone's sensor. And within it, like for example, the discrete signals, we've got Modbus registers within there, which can automatically calculate like events per minute. You can switch from NPN to PNP just by making a parameter change within that. There's a totalizer in there, a counter in there. You can mirror. So this is actually, the discrete has got a 2 in, 2 out, or it could be 1 in, 1 out, if that makes sense. So you can mirror an input coming in to an output, and that's all parameterized via, you could even use Modbus Pole. You don't have to use our software or anything. It's a Modbus device. And these are some of the new snaps that we've got, well, some new and old. We've got vibration temperature sensors, so we could monitor on 2 axes the vibration and temperature of a motor. That's quite a popular product of ours, isn't it, for condition monitoring and predictive maintenance. We've got CT clamps as well, current transformers. Is it one there? No. Current transformer. So that's quite good to put on a line on a 3-phase motor, for example, to look at the 3 different phases. They've also brought that out as an AC voltage snap. We've got a differential pressure for inlet and outlet pressures, temperature, humidity, non-contact, and thermistors.
So you can see here in the background there's the image of a motor, and what you're doing there is you're monitoring the CT for energy consumption, so you can do a cost analysis on that particular asset. You can see that when it runs at this percentage at max draw, it's costing you X amount, and that can all be converted and demonstrated on the cloud as one package. And then the vibration there is for your predictive maintenance. You might see that once the motor starts up, it spikes, but then eventually levels off. And then over a period of time, as the motor wears, bearings degrade, that the vibration increases, temperature also increases with it, follows suit. So you know that you might want to plan in some maintenance in the next scheduled window. And then that's all then displayed out to the cloud as well. There's another view, but what we're doing is monitoring the temperature via infrared with those 2 sensors there, and then making it a unified Modbus signal, which is demonstrated by the blue, feeding it into the controller, and then outputting back to the Modbus light. So you know that if it's amber, you might want to then plan something in. Goes red, there's a catastrophe about to happen.
Yeah, and we've got some Pulse Pro as well. So with this, so we could. We're big on visual factory, so it's making your machine, illuminating your machine basically. And what this is doing, we've got these current converters, so we can take an analog signal out of your sensor and convert that to a pulse output. So what that's doing, our lights are pulse input. So we do support PFM and PWM on our lights. So you can replicate the level again of that tank just from an analog signal. And this signal is basically sending a signal out from this sensor into a PLC. So you can process that analog signal in the PLC, but then you can also have a visual using our Pro lights. And these are some other examples of our Pulse Pro applications. And you don't necessarily need a PLC either. A lot of our sensors, well, our radar and our ultrasonic have a pulse output, and our Pro lights, like I said, have a pulse input. So you can simply just connect a sensor using one of our splitters. You just add power to it, and you can pretty much scale a light based on 4 to 20 milliamps. And again, the light, it's programmable, so you can set your different scales within the light.
We have this on display as well at our stand, this radar sensor.
Yeah, like I said, tank level we've mentioned, we use it for logistics as well a lot. So, forklift and warehousing, we can use it. And then distance on loading bays is quite a good one. Lorries can't really identify when they're going to hit the wall on a factory bay. So our lighting and our radars sensors, quite a good solution. We've got some inline indication as well. So these are quite unique as well. So we can add these onto a sensor. You got some power?
I do not.
Got some power. Let's just pop that in there. So it's quite good, if you've got sensors and you can't access the sensors, but these are quite good for fault identification on the sensor. So you can see sometimes, if you've got a bunged up sensor, if it's not an IO link or so, you can actually pop one of these inline indicators onto the sensor so you can see the status. So it's all part of our visual factory really, brightening up your process. And serial radios as well. I don't know if you want to delve into the radios.
Yeah, so a lot of the time running cable is expensive. It takes time and manpower. I guess you have to run the cable themselves. So what Banner have done is focus quite heavily on wireless technologies. So it's transmitting that signal without the need of running cable. These particular radios themselves, they will transfer data up to 1 kilometre, but we can get up to 3 kilometres using performance radios, and then have repeaters in between if the signal's bad. Maybe it's a factory with like walls in between, that sort of thing. And here's an example of some of the topologies we can do. So that's the repeater situation there, or if some instances require, you can have a master sitting centrally, have lots of different radios scattered around in a star topology there that you can see. And that's not just for our data capture. You see there we've got some push buttons there for what we call a pick-to-light system. And again, that's just transferring the data back to that cloud enabled gateway on the right there.
Yeah, and going back to the controller again, so this is a deeper look into the controller. So you've got your Modbus RTU ports here and here. So this is where we capture the data via Modbus RTU, which is a serial protocol. A lot of industrial automation equipment like inverter drives and stuff, PLCs have Modbus RTU connectivity embedded into them. And then, like I said, our sensors, you have a Modbus. So on the outset, we've got our industrial Ethernet port just here, that's power. And we've connected these to, we connected to our cloud and AWS. It's been tested by Banner, but we've been working with companies, a CMMS company called Agility, and we've proved that we can talk to Agility via a web server. MES systems as well, it will talk to, and MQTT. So that's like an internet protocol to talk to third-party clouds. It's where the OT and IT world have a bit of a handshake. So that's called MQTT. We've tested this on Kepware at a few sites as well. Being Modbus TCP, all you need to do is give the IP address and the Modbus register, and it knows, what device we're speaking to. And Modbus TCP, Ethernet IP, Profinet, that's predominantly the business, the sites we go to someone's either going to have a Siemens PLC or an Allen Bradley or Schneider, and it's easily you can easily integrate it with these manufacturers.
So, flicking back to the vibration sensors for predictive maintenance, that's one of these. It's tiny. So that's a Modbus sensor that can communicate directly back to a Modbus master and then send the data out to the cloud. But what Banner have done, nobody's a vibration specialist. They don't know what their motor's supposed to be running out on a good day. So they introduced VibIQ, which is a machine learning algorithm built into the sensor. So you trigger it, once all your sensors are mounted, you'll trigger that action to start the learning process, and over 24 hours it will collect enough data for it to make its own calculations on its threshold settings, so you know that this is good, this is maybe a cautionary, it's 15% above, and then again on top of that where you really need to take some action.
Some more slides. Yeah, this is this showing pressure on generally just identifying pressure. Same sort of topology. So we're taking an analog signal out, converting it to our unified serial protocol, sending it to the cloud, and again tapping off. That remains the signal going back to the PLC. This one's a signal that we converted, and then we're collecting that information and publishing it to the cloud. And a few more drawings. This is more condition monitoring. So we've got a CT, vibration temperature and pressure, and a non-contact infrared sensor as well. Are you guys familiar with IO-Link? Do you work with IO-Link and stuff like that? So everything that I've mentioned today is based on Modbus, but we have the same controller, same converters, but IO-Link. So this is a bit of an old slide, but it's showing our master going into. So it's all IO-Link going into our master, and then Modbus out into our Modbus controller. But now we have an IO-Link dedicated controller where these ports on here are IO-Link masters. We do that in a 4-port and an 8-port as well. But it's showing we can capture all the standard signals like discrete, analog, Modbus. But as well as that, we can capture, if you've got IO-Link sensors out in the field, we can get the IO-Link signal, put it through one of our IO-Link masters, and then come out on Modbus into our controller. And again, you can do all the manipulation, all the scaling within the controller, and then publish it to wherever you want to publish it to. It also shows our industrial radios there on the right, how we can, because it's a Modbus industrial radio, we can transmit the signal wirelessly if needed. So these are our IO-Link hubs. So we have them in different form factors. So we've got a two-port IO-Link master here. So these 2 ports are IO-Link, and then out of this port we talk Modbus. We do it as a 4-port IO-Link hub, and as you know with IO-Link, you can set it into different modes. So you can have IO-Link mode, or you can have discrete digital I/O mode. Standard I/O mode, sorry. And also the one on the right, that's our 8-port master as well. So that's multi-protocol as well. But the difference is between what I've been showing and that one, that's our 8-port version. So from that, you can daisy chain, you can add hubs to it, you can go directly into the controller via IO-Link, or we can add hubs to give you that extra I/O capability. And the profile as well, they're quite slim. So we do some bracketry and some accessories. So you can mount one on top of the other. And they're IP65, 67 and 68. So it's designed to be on a machine. So you don't need to put it into a panel. So you could save money when it comes to this solution. and these are some other topologies. So we could mix discrete signals via a hub into our IO Link master, or we can use our IO Link devices directly into the controller. Here's some more topologies of how we can use a 2-port IO Link to Modbus master, a 4-port, and it's just ways of capturing that data and sending it out to a PLC.
Excuse me, where is the power coming from?
From the, so this port here, that's a power port. So pins 1 and 3 are your power, pins 4 and 2 your signals on Modbus. So because it runs parallel, you get power out of these ports on 1 and 3.
24-volt supply.
Into it, yeah, that's right. Yeah, like here, that's just got power. So there's power in there, and then from each of these, you get power.
So the master will distribute power.
That's right, yeah. That's a good point, actually, because per controller, you're limited to 4 amps. So you just got to be aware, even though it's Modbus, we go with the Modbus rule, so you can have up to 247 devices connected to that, so on each of these RTU ports. But realistically, that's not going to happen because you're going to consume power. I know sensors don't take up much power, but some of our lighting does. So you just got to bear that in mind. But it uses all the Modbus rules. It's 1,200 meters, up to 247 devices, depending on how much current they're going to consume. There's a few more. And this is a way we can, the radios that Craig mentioned, it's a way we could wirelessly transmit IO Link signals as well. So we can use one of our IO Link 2-port masters. Got power on, like I said, it's parallel. So we power it using the splitter. The client is getting powered, and then the server radio is going back to the controller. So it's sending this signal from here, to here, to control the light wirelessly via IO Link. This is just a breakup of the different, so we've got 4-port hub on IO Link. The form factor, like I said, it's a nice small profile hub, and using our splitters, you can use an IO Link hub as a discrete IO port. So out of each port, you've got your 2 signals, 4 and 2. So we can split that using our splitters. So from a 4-port hub, you can have 8 signals going into it. Like I said, there could be NPN or PNP. We can basically change that around using Modbus registers. So it's all done via the parameters in the device. This slide shows, you know, we were speaking about analog input signals. We can also, we've got snap converters which output an analog signal. So for things like a pneumatic actuator or a drive, you can actually control a drive from it. So it's not only gathering signals and publishing it to the cloud, we can actually have an element of control. A lot of inverters, again, they have a 4 to 20 milliamp channel, so you could potentially run a drive using one of our IO Link to analog converters. And this just shows how we can run a drive and even control it via a PLC. Yeah, just recently as well, this technology is developed over a period of time. So it was just a matter of capturing signals at one point and sending data to the cloud easily. But over the last few, probably the last few months, Banner have released some remote I/O solutions. So it's actually becoming a bit more of a powerful, like a PLC type bit of hardware. So what we do have are our parallel splitters. So if it's on Modbus, we can daisy chain everything into one hub, being Modbus. But we also have these new, it's like a hybrid block. So this allows us to have 4 to 20 milliamp signal inputs, outputs, and discrete out of one remote I/O block. Again, we could mirror, so if we sent a signal into this port here, we could output onto that port there, just using parameter settings within the hub. We call it a smart hub. So within the hub as well, like I said, there's counters, totalizers, events per minute. You can swap PNP to MPN. There's quite a lot you can actually do in the hub rather than doing anything in the PLC. And these are our different types of controllers as well. We've gone through a few. This is our Modbus controller, which I've explained earlier. That one's our 4-port I/O link master. If you want an 8-port version, the one there, the DXMR 110-8K, that's our 8-port variant, I/O link master. And recently we brought out this DXM 1200X2. So that incorporates your 4 Modbus RTU ports, but it's also a wireless controller. So it's got a wireless transmitter within that controller, so we can send signals wirelessly back and forth, and we can also hardwire into the controller using Modbus RTU. It's got a nice indicator on the front as well, so it goes back to our visual factory where we can illuminate if the machine's healthy, we can show you green. If you've got a warning, we can show you yellow or amber. And if it's a critical issue with the machine, it can illuminate red. And these are our wireless controllers as well. Exactly the same as what we spoke here, but just pure wireless. And this is what a topology would look like if you're trying to capture your analog signals. So we capture these signals, whether it's 0 to 10, 4 to 20. We don't need 2 different products. We could capture them signals from out on the field and convert into I/O link, go into I/O link master, and distribute out of the Ethernet port. And as you know, I/O link, it's point to point, so you've got a maximum distance on I/O link of 20 meters. So this is showing some of that topologies. I'll just skip to here. Yeah, I was speaking about the 20 meters max. So with I/O link, it's got to be point to point. But the beauty with our kit, if you use the Modbus port on our master, we can have a Modbus network up to 1,200 meters, which will give you that extra cable length, if that makes sense. So you can combine I/O link with Modbus to basically give you more flexibility in terms of your cable runs. So things into the master could be 20 meters, but you can also have a Modbus network up to 1,200 meters. Well, we covered that one. And this is some of our wireless products as well. We have these vibration temperature nodes. They're battery operated, so you don't need no cabling. All we do is a simple triple click method. We can bind the node to the radio and send that signal back wirelessly. If we poll the device every 5 minutes on the 5th minute, we get optimum battery life. So you're looking at up to potentially 5 to 7 years out of the battery if you're polling it within that time period. But if you're looking to poll the data every second, then obviously you're going to use up more battery life doing that. But it's quite a powerful bit of kit, especially if it's really difficult to install cabling and stuff on your machines. That's similar, but using a DXM hardwired solution. So with our serial radios, they're powered by 24 volts. So you do need power. So that's showing the power coming out of the DXM into one of our client radios. And the other side of that, we're just using our splitters to provide power and analyse 3 motors. We've not really spoke much about the tech products, but that was Banner. But within our tech portfolio, we do have flow, temperature and pressure sensors. We also recently brought out a new radar sensor. So yeah, these come in different form factors, but you can incorporate this technology into our Snap Signal via analog output signals or IO-Link. That's what they look like. It's quite visual, quite a nice looking product. So you can see the flow detection and the status of flow or temperature via the sensor itself. If you use an IO-Link, you can parameterize the sensors via an IO-Link master. If you don't go with the IO-Link version, you can parameterize the sensor directly using the LCD pad on the front. And yeah, for more information, we've got a lot of marketing documents and brochures and stuff on online. So please feel free if you're interested to take a look. Like I said, Banner keep bringing out all the little snap converters. So every month there's something new coming out. So yeah, just log into our site and all the information will be there. Any questions on what you've seen so far?
Have you got a limit on data? A typical factory, would it be limited to data? Can that be infinite data, surely, is it?
Yeah, well, no, that's a good question, to be honest.
What controls the data then? Would it be cloud or would it be?
No, like the data could be coming. Like if you're connecting it to a PLC, you could send any of that data back to the PLC. But really, what we find, this is for like predictive maintenance, and it's not really a PLC. It's just a way of capturing the data. So we don't expect you to use this instead of a PLC because it's not got that sort of memory as a PLC or a computer or anything like that. We just use it to capture signals from like from your machines, like your critical signals, like vibration, temperature, things like that. Your PLC will do more of that process work and the hard work. And even with the IO-Link, I think it's 32 bytes on IO-Link. But sometimes we use our IO-Link master to convert to Modbus, but we take out the signals we want because we don't want to take everything out of IO-Link because there's a lot of parameter data, diagnostic data, process data. We just want to take out of the IO-Link device the data we need. Really.
How does the factory then control its data as a data protection then to secure that factory information? How would they control that?
Yeah, well, to be fair, we've had a few things. So they could have a firewall on their end. Sometimes the sites that we've been on, they're not nice when it comes to like connecting to their network. This is where we always go with the 4G solution. So we'd always say, you can connect from that 4G port to a third-party modem. Some of our controllers, they do have the DXM 1200, for example. That's got a 4G modem already built into it. So when it comes to anything like that, we would say, go 4G. And pick a SIM that's, you've got good coverage within that area. But when we are allowed on the network, the IT guys are pretty clued up when it comes to doing like the firewall and the certificates, the security certificates and stuff.
Can these be affected by any electrical interference? Can you pick any electrical interference?
What, like noise and stuff?
Yeah.
Do you know with our analog converters, we also do filters, inline filters.
Yeah, like chokes. And
Yeah, stuff like, well, yeah, do you know like EMC to get rid of harmonics and stuff like that?
Yeah.
But being a 3, do you know being a M12 unshielded, there's less resistance to noise. So that's a good thing with that and IO link. But if you're susceptible to noise if you've got inverters and big power drives and stuff, we do same profile as these, but they're EMC filters. So yeah, we've got all sorts. Yeah. We even do these as, do you know if you want to change the pins from 4 to 2, we do them like this. It's a certain part number, and it'll change 4 to 2, do you know, rather than having it parallel. You can order one with different wiring combinations as well, yeah. This is our demo as well. This is pretty much what you've seen on the screen. So that's a Modbus light. So all that's doing is taking a switched output from the sensor, and you can see the lights lighting up, and it's showing a count. So that's because it's Modbus, it's taking the discrete signal into the controller, and the controller's doing like a increment to bring on the Modbus register on the light. This one, that's actually using an analog signal. Is it analog? IO link, sorry. IO link to Modbus. So we're just taking the IO link signal, converting it to Modbus, and then you've got that tank level. And then vibration. This is a temperature humidity sensor. So if I put my hand on the front, you can see we use some of our indication, and it's got about 8 LEDs on the outside, so it's quite good. As that temperature warms up, you can see the outside LEDs going up, which is it's quite nice. It saves you having a HMI. As you can see, yeah, so it's gone red. So it's part of our visual factory, really. So we've got lighting within our portfolio as well, and it's all about status and lighting up the machine to know that whether the machine's healthy or not healthy.
Because how many people look at the dashboard?
Yeah.
You know, but you look at the light, don't you?
Yeah, exactly. Yeah. We get a lot of success with that. Even like for safety, we do the big WLS lights, and you could illuminate your whole machine based on if someone's gone into like a restricted area. So it's good indication, really, rather than using a dashboard. But yeah, it just gives you a few options: dashboard, local lighting. You publish it on a HMI. Yeah, it's quite a few different scenarios.
How user-friendly then is the software then, when you are doing conversions? Is that something you have to do in-house, or is it something the customer?
Yeah, no, customers can do it quite. Yeah, yourselves can do it quite easily. So everything's got slave ID as one. We've got so you can program that. You don't even have to use our software. You could use Modbus Pole, and you then set the IDs for each of your devices, because being Modbus, everything needs to have an ID. But then the register map is, if I show you, just a simple. If I show you just a simple B20, this is a discrete converter. So normally with I think it takes a bit of time.
You've broken it.
Didn't do anything as well. Did I touch something here?
Yeah.
Oh, there you go. So this is a typical data sheet of one of our discrete converters. So a normal sensor will be either on or off. But from this, so these are the registers. So 4001 would be your active signal on or off. Then you've got these built-in counters. So your lower word pin 4, so when the signal goes from 0 to 1 on pin 4, that will increment, and then when it gets over 37,000 or what, 65,000, it will increment your higher counter. You can see how long that pin 4 has been energized for, so it does a calculation to tell you how long that's been on for, and events per minute, so that's good for OEE. But what it is, you then read that value.
Yes.
You know, from the controller in our software, read Modbus register 8. It will be 8 because everything's done via holding register. So we leave off the 40 and just say we want to look at slave ID 1, register 8, and that's how you get the value in, really. But yeah, by all means, if you're interested, we do site visits and stuff like that. We can always, you know, like help you with the software and stuff. But in terms of data capturing, it's relatively straightforward. It gets a bit more complicated when you're, you know, writing the scripts, or you write in some kind of Python, or, you know, getting a bit more, you know, using it a bit more, you know, with a bit more, what's the word? Sequencing, yeah, bespoke, yeah. But to capture data, it's relatively simple. Yeah.
Any other questions?
Yeah.
Thank you.
Cool.
Thank you.
Yeah. Cheers for that. Yeah.
Thank you.
Nice one. Thank you very much. Cheers. Thank you.